Well, hello students. Today we're going to learn about finding the midpoint of a line segment and also finding the distance between 2 points, which could be on a line segment or a line. This first example, example 1, if you look at your notes, you can count over and up, and the ordered pairs are -3, 5, and 0, -5 on that line segment. Now, to find the halfway point, that's what the midpoint is. It's really easy. All you do is you add up the two x values and divide them by 2. Add up the two y values and divide those by 2. You're basically taking the average of those 2 points. So the x value of the midpoint would be -3 plus 0 divided by 2, and so that would be -3 halves, or if you wanted to call it -1.5, that would be fine. The y value, again, same deal. You add up the two y values and divide them by 2. And 5 plus -5 is 0, and 0 divided by anything is still 0. So the midpoint ordered pair would be -3 halves, 0. And they all work like that. And so that's example 1. All right, students, now for example 2, it's the same type of problem, but a little bit different. In this case, you're given one endpoint, you're given the midpoint, which will be the same distance, but then you need to find the other endpoint. And I like to draw sketches whenever I can. Now, I'm going to use my head a little bit. Since this midpoint is negative numbers, I'm going to put -4, -7 here. That endpoint I'll call point B, 5, 6, and I'm trying to find point A. And there are a couple ways you can do it, but one way that's easy is just ask yourself, all right, from 5 to -4, how many units did that go? Well, it went on a number line. It went down to 5, and then into negative territory it went 4 more. So that was 9 units to the left. So if we're starting at -4 and we go 9 units to the left from there, because this is the halfway point, remember, so -4 take away 9, we're going to be -13. Similarly, the y values from x down to -7, that would be 6 and then another 7, so that's going to be 13 units. In this case, since it's a y value, it'd be down. And so if you're going another 13 below that, -7 minus 13 is going to be -20. And I think that's the easiest way to do these particular problems. And that's example 2. All right, students, now for example 3, we're going to find the distance between 2 points. And there is a formula you'll have to commit to memory. Most of you have seen it last year in Math 1, at least briefly, and I'll give it to you in just a moment. But on your notes, you'll see your line segment. And if you will count over and up, you'll understand that the ordered pairs are 4, -1, and -1, -4. And we're trying to find the distance between those 2 points. So the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And so because we're going to be dealing with a radical very often, you have to simplify it at the end, break it down, but we'll get to that if we need to. Now, it does not matter which ones you call x sub 2 or x sub 1. I'll probably call that x sub 2, y sub 2, that x sub 1, and y sub 1. It does not matter as long as you keep the same thing going. So let's plug in the numbers. The square root of x sub 2 would be 4 minus x sub 1 is -4. So a minus and negative, we'll realize in a moment, is a positive. Plus, y sub 2 is positive 1 in this case, minus y sub 1, which is negative 4. So again, we're doing minus a negative. And I just realized I made a mistake. X sub 1 is not negative 4, it's negative 1. So let me change that, and let me double check my work. 4 minus a negative 1, 1 minus a negative 4. Okay, we're good to go. So the distance then would be the square root. All right, 4 minus a negative 1 is 4 plus 1, which is 5. 5 squared is 25. Plus 1 minus a negative 4 is 1 plus 4. That also would be 5. 5 squared is 25. And so the